SPH4U motions in a plane. 1.4 Projectile motion. Projectile motion is a motion of an object thrown or projected into the air, subject only to the acceleration of gravity. This object is called a projectile and its path is called its trajectory. Note that the x and y components of motion are independent, with only time connecting them. So the y component has constant downward acceleration, which is g, or 9.8 meters per second squared, down. And the x component, the velocity is constant, therefore acceleration is 0. So if we have, this is a projectile, and this is its velocity. It can be broken down into its y velocity, x velocity, which will be important while solving projectile motion questions. The best way to understand how to do projectile motion questions is to try doing some. So this is an example of projectile motion question. So a cannon is fired off a 30-meter high cliff. The initial velocity is 85 meters per second, right 20 degrees up. First, draw a sketch of the problem. Then we had to find out how long is the cannonball in the air before it hits the water, how far from the base of the cliff does the cannonball hit the water, and what's the maximum height the ball reaches. Alright, so first we're going to start off with a sketch. It's always good to have a sketch to visualize the problem. And when we're doing the sketch, we can also set our reference frame. So we're going to set up and right as positive. Alright, so you know that the cliff, 30 meters tall. And we can draw the cannon here, shooting out a projectile. And we know that this angle here is 20 degrees. And we know that the velocity is 85 meters per second. So, if you're looking at the velocity in more detail, you can see that it makes a right angle triangle. So we can break it up into components. So this is actually the initial velocity, vi. So v I y, v I x. So we can break up this velocity into its components right now. So v I y is equal to 85 sine of 20. So that is equal to 29.07 meters per second up. Vix is equal to 85 cos of 20. So that is equal to 79.87 meters per second. And the direction of this would be right. Now that we have visualized the problem, we can move on to part B. How long is a cannonball in the air before it hits the water? So you may think that we could use this equation. Velocity is equal to the difference in displacement over difference in time. But in reality, we can't because we don't know what the displacement is. So instead, we'll have to use the kinematic equations as well as some quadratics. So first, let's set out what we know and what we're trying to find. So acceleration is equal to negative 9.8 meters per second squared up. We know that VIY is equal to 29.07 meters per second. And displacement is equal to negative 30 meters. Displacement in the y. We know that this is negative 30 meters because on this cliff, we can assume that the reference frame is positive here. So these 30 meters are actually negative. So, and we're trying to find time. So we can use this kinematic equation. dy is equal to vi y plus times t plus 1/2 a t squared. So negative 30 is equal to 29.07 t plus 1/2 times negative 9.8 times t squared. So if we set all this to equal 0, we have 0 is equal to negative 4.9 t squared plus 29.07 t plus 30. So if you can see, this is actually a quadratic equation. So in order to solve for t, we can use the quadratic formula. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So t is equal to negative 29 plus or minus square root of 29 squared minus 4 times negative 4.9 times 30. And all this can be over 2 times negative 4.9. So if we plug this in and we solve for both the negative 2.9 plus everything in underneath this square root and minus, we get two results. T1 is equal to negative 0.89 seconds. T2 is equal to 6.8 seconds. We know that this T1 is inadmissible because you can't have negative time. So we know that the time is 6.8 seconds. So we can write a statement. Therefore, the ball is in the air for 6.8 seconds. Now that we've done B, we can tackle part C of the question. So it's asking how far from the base of the cliff does the ball hit the water. So for this, we can actually use the equation velocity is equal to displacement over time. So we know that time is equal to 6.8 seconds, and that's because time is constant between both the y and the x component of the projectile's motion. And we found 6.8 in part B. And we know that the velocity in the x is 79.87 meters per second light. So now we need to find the displacement in the x. So if we just rearrange just using some simple algebra, we can find that displacement in the x is equal to velocity in the x times t. So displacement in the x is equal to 79.87 times 6.8. So displacement is equal to 545.5 meters. So that's how far away from the base of the cliff the cannonball hits the water. Part D is asking what is the maximum height that the ball reaches. So let's redraw our diagram to help visualize this. So know the cliff is 30 meters tall. This is the trajectory of the projectile. So this is this maximum height. So basically what this question is asking for is that we find this displacement above the cliff plus the 30 meters of the cliff. So we know that VIY is equal to 29.07 meters per second up. And we know that VFY, since this is the maximum height, is equal to 0. And we also know that acceleration is equal to negative 9.8 meters per second squared up. So what is displacement? So in order to find displacement, we can use the equation Vf squared is equal to Vi squared plus 2 times acceleration times displacement. So we can set this to 0 since we know that Vf is equal to 0. So 0 is equal to 29.07 squared plus 2 times negative 9.8 times displacement. So if we isolate for D, we find that negative 841.58 over negative 19.6 is equal to displacement. So, and that's equal to 43.1 meters. So in order to find the max height, that's equal to 43.1 plus 30, so that's equal to 73.1 meters. So this is how you would approach a projectile motion question.